All right, let's walk through the Unit 2 learning targets 4 through 7 and number 9, practice assessment. So part of the learning target number 4 is being able to distinguish between an element and a compound. Remember, an element has one capital letter at the most. So for letter A, when you see two capital letters, automatically that is a compound because it has nitrogen and iodine. But letter B is just an element. That's nickel because it has one capital, one lowercase. Letter C is another compound. It's got capital C and capital O. Letter D is back to an element, one capital, one lowercase. And letter E, technically a molecule, but we're not going to write compound because it doesn't have two or more different elements. Learning target 6. We need to be able to fill in all of this information about these elements. So let's talk about fluorine, number 9 first. The symbol for fluorine is just an F. It's number 9. So that means it has 9 protons and 9 electrons if the atom is neutral, which it says it is. The average atomic mass, we're going to need to go and look at that. 18.998. Which means the most common mass number is 19 because that's the closest whole number. So to get the neutrons in the most common form of this atom, we do 19, which is the mass, minus the number of protons. That is equal to 10, the number of neutrons. Is it a metal or a non-metal? Well, it's to the right of the zigzag. All of these to the right of the zigzag are non-metals. Also, fluorine is in group 7A, which we're going to need that information soon. So it is a non-metal. It is in group 7A, and that is the halogens. How many positively charged particles does this atom have in its nucleus or outside its nucleus? Well, it has 9 positive protons in its nucleus because protons are found in the nucleus. And it has 9 negatively charged particles outside the nucleus because electrons are found outside the nucleus. All right, now we do everything for strontium, number 38. So if we look up strontium, here it is. Symbol is SR. Number 38, so it's got 38 protons and 38 electrons, assuming neutral. Its average atomic mass is 87.62. That rounds to 88. So we do 88 minus 38 to get the number of neutrons, and that's 50. Now it is to the left of the zigzag, and everything to the left of the zigzag is a metal. So strontium is a metal, and it is part of group 2A. Group 2A is called the alkaline earth metals. It's got 38 positive protons in its nucleus and 38 negative electrons outside the nucleus. Question: why does the mass number of an atom only include adding protons and neutrons? Why not the electrons? Well, that's because electrons are so tiny. Their mass is negligible. It's just they're so small that we don't need to factor those in. All right, learning target 7 is about isotopes and being able to complete information about these isotopes. So the first one is chlorine-36. So let's look up chlorine's atomic number. It's number 17. Okay, so that means that chlorine is going to have 17 protons. Now, to get the number of neutrons, we've got to take the mass minus the number of protons. And that comes out to be 19 neutrons. Silicon has 14 protons. That's its atomic number. And to get neutrons, we need to do 30 minus 14, 16 neutrons. All right, and then we've got element number 11. So we can go and look that up. Number 11 is sodium. So for its name, it's going to be sodium dash, what is this mass? 11 plus 13, that's 24. And then its symbol would have the mass in the upper left and the atomic number in the lower left. Now we're on to this puzzle. All right. You want to put a capital U, it says, in the place where the most reactive metal goes. Well, the most reactive metals are group 1A, the alkali metals, and they get more reactive as you go down the group. So we're going to put a letter U right here. T is the heaviest noble gas. The noble gases are group 8A, and the heaviest one would be at the bottom. So we're going to put a T right there. R is a gas that humans need in order to survive. That sounds like oxygen. Oxygen is element number 8. It's in group 6A. So we're going to put a capital R in oxygen's spot. Exclamation point is a stinky yellow powder and has similar properties to oxygen. Okay, let's look at oxygen. So it would be in the same group. Ooh, that sounds like sulfur. I've heard of that. Sulfur is very smelly, like rotten eggs, and it is a yellow powder. So we're going to put an exclamation point on number 16. Capital C is the lightest of all elements. Well, that's number 1. That's hydrogen. Lowercase c is used to make pop cans and has 3 valence electrons and 3 shells of electrons. So row 3 for 3 shells, and group 3A is 3 valence electrons. So that goes to right here, number 13. Let's see if this makes sense. Number 13 is aluminum, which, yeah, is used to make pop cans, so that's good. Capital M is the lightest alkaline earth metal. Well, the alkaline earth metals are group 2A, so this would go here, capital M. Colon is a halogen used in table salt and has 7 valence electrons. Okay, well, that's helpful. It's in this group, 7A. Which one of these is in table salt? Chlorine, chlorine, or bromine? Sodium chloride. So we're going to put a colon in number 17 spot. Lowercase I is a liquid at room temperature, and it's in group 7A. Let's use the periodic table. There's not very many liquids. Bromine is one of them, and the other is mercury, and then element 114. But there's only one that's in group 7A, and that's bromine. So lowercase I will go in bromine's spot. Capital H is a non-metal used in balloons and blimps. That sounds like helium, which is number 2. So put a capital H in helium spot, even though the real symbol for helium is capital H lowercase e. Capital E is an alkali metal that's used to make watch batteries. Okay, it's got to be either lithium, sodium, or potassium. Those are in the alkali metals. And I've heard that lithium is used to make batteries. Capital S is an element found in diamonds and graphite and has 4 valence electrons. So our choices are carbon, silicon, or germanium. Well, I've heard that carbon is used to make diamonds, or is what makes diamonds, I should say. So capital S goes in carbon spot. N is the heaviest member of group 3A. So we're going to go to group 3A and we're going to write capital N at the bottom because they get heavier as you go down a group. Capital T is an element that makes up most of the gas in our atmosphere and has 2 shells of electrons. So it's a gas and it has 2 shells. So it's going to be number 7 or number 9 or number 10 are options of the gases. So it's nitrogen, fluorine, or neon. Well, we've talked about how nitrogen makes up most of the gas in our atmosphere. So that's going to be a capital T. Erase my lines. Lowercase r has the largest atomic radii in period 3. That's going to be this one because it has the least number of protons to suck in those 3 shells. So it will be the largest. K has the smallest ionization energy of elements 1 through 36. That's in group 2A. So group 2A, it's easiest to take one away from the biggest. So that would be number 20. Lowercase k is used in computer chips because it's a semiconductor. Ooh, I know that one. It sounds like silicon. Silicon is number 14. So that's a lowercase k. Underscore is used in lighted signs and has the smallest atomic radii in its period. So it's used in lighted signs. The smallest ones are over here because they have the most protons for their row. So it's either number 10 or number 18. Neon is used in signs. So I'm going to do an underscore. Asterisk is a member of group 6A. Oh, there's only one left here. Capital I has the element symbol B, so that's boron, which is the top one in group 3A. What was the letter again? Capital I. Starting to see it spell something. Capital W is a type of poison that has 5 valence electrons. So it could be either number 15, phosphorus, or number 33. Ooh, we talked about arsenic being poisonous. So that is going to be a W. Capital Y is found in period 2 and is a very reactive nonmetal. Well, there's only one left in period 2 that's blank, right? In that row. So it must be fluorine, which is a very reactive nonmetal. Lowercase o is an alkaline earth metal in period 3. So period 3, the alkaline earth metals are group 2A. So an O goes there. Capital O is the heaviest element in group 4A. The bottom of group 4A, good. Lowercase s is used in match heads. It has 3 shells of electrons and 10 core electrons. So 3 shells, okay, and 10 core. Ooh, so 15 minus 5 is 10. Yep, so that works. So this is a lowercase s. Nice. And then a parenthesis is a part of the group that's inert or non-reactive, and it's the hardest to take an electron from in period 3. So it must be the one on the end. Nice. And then let's look at our puzzle. Chemistry rocks, you know it. Nice. All right. A couple of short follow-up questions from the puzzle. Why does the answer to number 18 have the smallest radii in its period? The answer to number 18 is neon. Neon has 2 shells, okay, like the other elements in period 2. However, neon has the most positive protons in period 2. And the protons attract the negative shells closer to the nucleus, making a smaller radius. Right? It makes sense. They've got the most positive protons in the core, so they're sucking in those shells, making it have a smaller radius. Why does element number 11 have a smaller atomic radii than element number 19? So element number 11 is sodium. Why is it smaller than potassium? The answer is it has less shells. So element number 11 has less shells, only 3. So 1, 2, 3 shells of electrons, while this one has 4 shells. 1, 2, 3, 4. So it's larger. Why does the answer to number 26 have the highest ionization energy in period 3? So the answer to number 26 is argon. Why is argon the smallest in period 3? It has the most protons in its period. So just like our answer up here, so the protons attract those negative shells closer to the nucleus, making a smaller radius. I didn't really realize that was kind of a redundant question there. Oh wait, this isn't asking why it's smaller. It's asking why it has the highest ionization energy. So let me follow up. The smaller the atom, the higher the ionization energy, because the electrons are closer to the nucleus. So, and they're held closely by the protons. Those protons are attracting those electrons, so it's going to be hard to snatch one away. Does element number 18 have a higher or lower ionization energy than element number 10? So element number 18, does it have a higher or lower ionization energy than number 10? Well, it has a lower. Number 18 has a larger radius, more shells, so it's easier to remove an electron. There you go. Hopefully that helps you out.